Cool. So I have a deck at least for this session, but feel free to interrupt. Like, I think there's been a few conversations around this in the past with some people that have been involved here. There's going to be a little bit of repeat, but since I think we have all the brain power in the room, we should make use of it and discuss things as they come up. So I gotta go through things a little bit. Progressive web metrics is it already has a name in capitals. It has like a brand name. It's probably a little bit too early for all that, but it just seems so attractive to do all that. But the idea here is what are our, as Chrome web platform, but also for web developers, what are the top metrics that matter most? If we were trying to capture the summary of how successful the user is and measuring their delight, how do we do that? So in the past, the metrics that kind of have existed and are terrible generally are things like PLT, which is pretty much the window load event, not representative of much really at all. Not content loaded, same challenge. In UMA, loading team has deprecated all the PLT dot metrics, although I do see, I think there are still some in being watched. But so we're moving away from these old and not very strong signals to something better. I think there's a few requirements here of a system of metrics to keep things in check. First of which, it's kind of the most important, that it actually represents the user and their perceived performance. The closer that we can get to having a numerical representation of how happy they are, the better. The system cannot be gamed. We really want to minimize the ability to optimize for a certain metric when it might not actually be delivering user value. A good example here is if you server-side render your entire site and you get out that first paint that is also the first meaningful paint, it's like the ending state of the page. You can do that really fast, but if the JavaScript thread if the main thread is just busy for the next 5 seconds doing JavaScript, 12 seconds. It's not right. 10 seconds? 12 seconds. Yeah. I profiled the mobile Reddit site a while ago, and they had they got their first meaningful paint out in like 2 seconds, and then on my phone the main thread was busy for 45 seconds. I could actually there was composited scrolling, so I could scroll, but I couldn't do anything else. So that was something. Right. So that is not that example. Like, we would not want to reward them with a great score.
Just to be clear, it's okay if one metric is gameable as long as that would cause you to hurt another metric.
Exactly. Yeah, I think that's right. I think it's pretty much that.
The system as a whole is not.
Yeah, the system as a whole. I don't. Yeah, it's. I think it's hard to summarize everything into one singular thing, but let's identify the components that keep each other in check. We want to make sure that these metrics actually make sense for modern web apps, and so that means that the way that we consider, the most important thing here is that the way that we consider load always starts from navigation start. It is a real page load, but if you look at desktop, Facebook, Twitter, Netflix, YouTube, all of the navigations inside of the site are a bunch of XHRs and JavaScript. They're not navigations. So I think that's, if we're looking at having better definitions here, we should identify that we can deliver the same sort of value metrics for non-navigations. And then I think this kind of got brought up a little bit yesterday in Nat and Annie's talk, but there's a lot of kind of more atomic perf metrics all over the place. So this was a slide from their deck. And so these are kind of like the top level metrics for all the various teams. And I think, I'm excited about finding how these kind of come together. What is the hierarchy that we can identify, how exactly V8's work, contributes to overall user happiness. I started, putting together a little DAG. It's totally unreadable and kind of useless, but I'm thinking like this sort of approach where we can identify the relationships is good. Input dev has a really nice structure here. I want to show it a little bit later. Okay, so taking load as an example, I think in the past we've tried to represent load with one specific number, and I think it's hard to. Load is kind of a journey. It is a number of different points, and they all matter differently. And so Kenji summarized this, that there's a few key user moments that we're interested in. First of which is it happening? Pretty much like I started navigating, like, is the page actually, gonna load, or am I just gonna be looking at a white page in a spare the entire time? Like acknowledgement that yes, you have started to load the page correctly. After that, like, has the page delivered enough critical content that I can be like, okay, yeah, this is the page, and I could start engaging with it. But then there's a question of like, can I actually engage with the page? And then lastly, it's not really a moment per se, but it's a question: is this experience delightful? Kenji, I just want to. This is all you. This is all you. So there you go. All right. So, yeah, I'm going here. Sorry. This is the current draft of what progressive web metrics is, let's identify and sort of get a little bit more specificity here. So there's certainly an area around load that we're interested in identifying these key user moments. The first meaningful paint has had kind of the most mature work recently here, and in addition to kind of identifying these user timings along the load lifecycle, there's also metrics that characterize the sort of experience, both during load and then just in general for the entire lifetime of the engagement. So those are all at the bottom. So I'm going to go through a few of these and touch in more detail. Smoothness, I think we have a decent handle on. I think generally breaks down into the frame throughput, how close we're hitting 60 FPS, and also a discrepancy which identifies that, big janks feel really bad and we want to account for that. However, Tim told me that last night over beers, you guys sorted out like how exactly we're gonna fix this whole smoothness.
We had some ideas.
Yeah.
You remember them?
I do. So I really like. We were talking about frame throughput.
Yep.
And a couple some of it just we had some ideas in implementation. We want to include both the main thread and the compositor thread. One insight that made me feel a lot more comfortable with life was that I think we can bake in checkerboarding into hurting frame throughput, which makes me happy.
Yeah, I think that's.
And I think this covers a significant fraction of the input cases that we care about. So I don't think we need a separate scroll smoothness metric.
Yeah.
This is all good.
Yeah, I got the same feeling that scroll smoothness is the same as animation smoothness, and it's all about just that fidelity. Cool. Byte efficiency. This is interesting. A lot of web developers, talk about the total like kilobyte, the size budget for their pages, and they're like, oh, well, this page is, it went from 450K to 500K, and that's bad. But it's really not like that's the size of the page does matter, but it's not exactly has a high correlation to the actual loading performance. But it does still matter, and so the question is like, what is the user-centric view of network data consumption? And I think the answer is pretty much it's money. And in certain cases, you're on Wi-Fi, and if that connection is totally free, then you're just like, use whatever you want. I don't care. I mean, make it fast, use the data. But in other cases, you're paying, and it matters. So what does my site cost, actually represents this, and web page test actually uses a service on every single run. So what they did here is they calculated the total cost of bytes in various markets, and so you can just run like just find out how much the site costs, and then get an actual total cost. It's like 13 cents, $2. Apple.com doesn't do so good here, but a lot of people don't. So yeah, so I think byte efficiency is kind of Jules ends up in kind of the cost.
Like you could argue that maybe that site was expensive, but it was worth it.
Mm-hmm.
Right? Or you could argue that actually it was not so expensive, but it could actually do a much better job if it were to use like better compression and so on.
Yeah.
Like, is there any additional notion we need there?
Yeah, I think we were looking at those, like the site engagement scores, like the karma scores, and I think that's kind of a signal. If like you have a high site engagement, then you're kind of like you're bought into it, but you don't want a site out of nowhere to be to be triggering 5 megs of download.
I have kind of the opposite reaction. If it's a site that I'm engaging with all the time, I would really like it to be cheap.
Yeah,
I don't.
Yeah, true. Yeah. Yeah. So I don't know. I think there's more to it. Kind of early here. Input latency. This is a nice. Who did this? Who did it? So this is. Do you want to describe?
Sure. So like during the life of a touch move event, there are a whole bunch of important points in time that we care about. And so we have names for each of those points in time, which are in the square boxes. And then we also want to report some metrics. And so those metrics are the dotted arrows with names, and that indicates what the UMA metric is called. And so frequently what happens is we'll look at a pretty high level metric that spans a significant fraction of that graph. And then when we see a regression, we can look at which of these sub-metrics actually regress to give us a better idea of where to look at.
Yeah, so that, like these outer ones are kind of like received on the compositor to frame painted.
Yes.
Yeah. Yeah. So I think generally the latency has good shape of things there. I want to touch on speed index, and it is certainly gameable, but it does have a lot of value in the fact that it is the closest representation to what is actually on the screen that we have, and does a pretty good job at representing that. So this is actually a nice, this is a standalone little project called Speedline that takes a trace and uses the screenshots captured, and then just does the pixel analysis on that screenshot, on the screenshots, and just uses the speed index algorithm that WebPageTest shares. And so it's charting both the visual progress, and speed index is basically it represents the median value of this histogram. It's a good thing. But it does have problems. Speed index, this is the visual progress of another page. This one, as it loads, it starts out and then goes across, and then you can see, we got kind of the ending point, but then all of a sudden the image carousel switches over to some other promo and then switches to another one. And so when we're trying to compare how far we're progressing to our endpoint, the endpoint is hard to define in a way that's generalizable across all sites. So there's some tricky stuff there. First meaningful paint is Sakamoto-san has done some fantastic job there. I encourage you to read through this doc. And I think to me at least, it seems like it started out as, let's identify kind of a baseline time at which we started looking at layout significance. But then what I really like about it is kind of started out as layout significance, looking at the results, and then they looked good, but then we start to identify that once the page is, that we want to kind of account for how tall the page is. So then there's kind of a calculation here that uses the size, the height of the page to fill into the significance of the layout. And then we're like looking at the results, and then turns out that there's still a bunch of cases where web fonts haven't loaded, and so we have invisible text. And so time to first meaningful paint also considers how much of the text on the page is still invisible, and waits for enough of it to be visible to say this is meaningful. So it's, it started as something simple, but as we analyze it, identify what tracks the user most closely, kind of fill in some details.
This is likely a dumb question, something you've thought about already, but it seems like not all portions of the page are equally important. Could we weight the stuff that the user actually cares about and say, like, when that stuff is loaded, like that's more important than when all like the the superfluous crap is.
This is sort of why we've been talking about some double latching of time to interactive and then visual completeness sort of in the viewport. Because at that point, if you've got pixels on screen and they're interactive, you're in a good spot from the user's perspective. Whereas if you have pixels on screen where everything's painting, but you're still locked on the CPU and you're not interactive, it's not really a great experience yet. So,
say for example, you're interactive, your content is on screen, but your ads have not yet loaded.
The only question is, does their loading jank you? And if the answer is no, then life is good because they'll come in sort of as they do. Today, what we see is in a lot of cases, Jake Archibald always gives me the example of like, well, I don't want to I don't want to count something that's being done if the carousel that's loading at the bottom of the page is going to jank me. It's like, well, yeah, we need a metric that includes, that only gives you credit really for interactivity, plus, at the point past where you've meaningfully put content on screen.
Yeah, and I do think I agree that like even for this web fonts portion of FMP, it's not necessarily sensitive to where that text is. Like that text could be at the very bottom of the page and kind of like the footer, and you don't really care. So I think that there is room to account for the position of some of these things a little bit more. Yeah. Okay, so yeah, let's get into time to interactive since we just started on it. So time interactive is generally the idea of like we're looking here at, I guess, like on the second mark, we have the page is kind of visually ready. It's pretty much done. I guess it's missing this ad on the bottom, but it's not the first meaningful paint. It's pretty much like I would be like, okay, yeah, it's done. I'm gonna start scrolling. I'm gonna tap on an article. But if the main thread is just completely pegged to that point, I'm not gonna get very far. So we want to identify the time at which the page is available to me. Yeah, so I'll walk through kind of the way that I've been kind of framing this so far. And it has some subpoints to it. So first thing is that the user requirement number 1, is that the user believes it's visually, done enough. They could start interacting with it. So layout is generally stable. Key web fonts are available. Pages are also visually complete enough that you're like, okay, yeah, cool. So some banner ads might be missing, but you're okay with that. The loading spinner from the browser is probably also done at this point. Notice that people usually wait for that to kind of finish. But then we get to the second part, which is that the page is actually ready. One thing here I think we want to do is wait for DOM content loaded, because we could have a lot of event handlers waiting on that might change the page, or just be setting up event bindings that we will need to rely on for the user. And then the main thread actually is available enough. So I'm going to walk through a definition of expected input latency.
Just a question on that last slide.
Yeah.
User agent loading indicator is done.
Yeah.
If that was ever actually the bottleneck, I think that would indicate that our loading indicator is probably broken.
Yeah. Basically, and Japheth is changing how our what our loading indicator is bound to. The current logic on loading indicator is that it waits for DOM content loaded and in-flight critical requests to be.
So does it make sense for that to be one of the requirements here? If we're just going to move it around until it.
I mean, I guess I see it as a visual signal from the browser to the user. I think it's a sub-requirement that it is good.
Yeah.
So like if we rely on it, we need to make sure that it is good enough.
And there probably will be edge cases, no matter how good we make the spinner, right, where the user still doesn't believe that it's loaded because of the spinner.
Yeah, historically the spinner had some definitions around waiting for load event of the top frame and all iframes. Like,
Right.
I don't think anyone in this room would like it to do that. So yeah, we should pay close attention to it. All right, so yes, here you go, Alex. You loaded up a content-heavy site, and like it's visually painted, but the scrolling is locked. So how valuable is that? So expected input latency has had a few names. This is one name. Input hazard, main thread availability, long tasks. Just yeah, the effect of the main thread on the user. So I'm gonna walk through the approach that we've been prototyping with Lighthouse. But there's some other possibilities. So basically, we look at the top level tasks on the render. We get a distribution of how long all of them are, and then we use that to calculate the queuing time that we would expect until we can actually handle any high priority input task that's coming in. So like this is a trace that was loading up, I don't know, google.com, something like that. We're looking at a second worth of the render thread, and I've just selected across the top for all top level. And so we have 224 tasks in that time, and you can start to see the duration of all the tasks. There's certainly like this big guy right here, but then there's 200 other smaller ones. And so one thing here, and I guess maybe Sammy you can confirm, but it seems as though the key thing here that we want to make sure is like there's clearly a lot of work happening, but we're not necessarily trying to find that or note that it's just a lot of work. But if there are breaks in the tasks, that gives the scheduler the opportunity to interrupt and be like, hey, high priority stuff, I'm gonna handle this right now.
Right, yeah. And for that, you actually don't want to look at the top level. You want to look at the next level down because we batch things.
Oh,
and we can switch inside a batch.
Cool.
So
okay, yeah,
way more accurate that way.
Nice. So yeah, so in this case, like this like clearly this long task is no good. Yeah. But up in here, like yes, we have a bunch of work queued up and it's busy, but we have an opportunity to at least insert one task. Cool. So yeah, in this approach, we kind of take all of these tasks. So this is just a histogram of the durations of all these tasks. You can see a bunch of them are really, really short. And then here's a long one out here at the bottom. And so we take those. In this little animation, we have only 7 tasks of a few different lengths. And we plot them out and see if we were to have input during any of those tasks, how long would we expect to wait to actually handle that input. And so we plot that out, and then we can actually just do the CDF to calculate the probability of for any input during that time range, what is the probability that I would have to wait X amount of milliseconds in order to handle the input. So that's kind of the look of that. But I know both Ned Nguyen has done some work around this, and you've been looking at this too. So I don't know, what did folks think about how to kind of incorporate main thread busyness into this kind of user-centric loading stuff?
Well, if it's about loading, right? If it is about loading, then when it happens, to my mind, seems to matter. So let's say, that cumulative distribution function is really eye-opening because it shows you kind of that in some cases you're going to be really up against a tough thing.
Yeah.
But if that big block happens relatively late, or there's a bunch of empty time and then you do it.
Yeah.
It's not clear that from the user's perspective that's a great experience.
Yeah, right. Yeah. So let's say like big, so like in here towards the end of this trace, like, it's spaced out, we're pretty good, but imagine there's like a big, huge block right after that. Yeah. And so that's a good question. Like,
so this is why I've been favoring the notion of trying to do loading, determining when you're done loading by that double latch thing where you start with, am I painted? Is there something that I can interact with? And then walking from the back of the trace to try to fit a window that says, at what point would I have become interactive, like meaningfully interactive for the rest of the trace? Because if you do that backfitting, then what you find is that like maybe there was a point early where you would have been interactive, but then you would have been very disappointed to try to keep using it because that long task got scheduled and then you can't do anything.
It just feels similar to the animation, right? So if you can have overall like 60 frames per second for a long time, but you do have like jank, it kind of feels similar to that, right? You have like the same kind of similar issues.
So I think this is a great trace actually to show what a good site could do, which is to say bunch up a bunch of its work, and then those look like animations, but if they're not animations, to make sure that you schedule things such that they're sliced, at which point you could get credit for having painted pretty early, at the end of that first initial block. Whereas if you had moved that block to some point later, you shouldn't get credit because you're hanging the UI.
Like in terms of sort of scoring a metric, it feels like that. Yeah, the later you are, the higher really should be penalized for sort of stopping them. But like if you stop input, during the initial load, like the user isn't expecting anything to happen, right? But it's still a nice thing if it does. But
yeah,
I think we talk about load, and I think about load as like you mentioned the word acknowledgement earlier in terms of Kenji's description of time to first meaningful paint, and I think that's we're getting a user something, and then the question from the user's perspective is, can I use it?
Right.
And what's the variance? How much does it hurt to try to use it? Will I be astonished? And from the principle of least astonishment, the user wants to have predictable performance through the rest of the application's lifecycle. And so if we optimize for, at what point did I become predictably performant about the pixels that are on screen? Like, at what point are they actually usable? I think we get to a place where the user model feels, intuitively, it's not a tight correlation. I think we need to do a lot of user research to understand, if we added like long janking blocks, how big could they be? When could they be? That sort of thing, and we can actually run those experiments. But intuitively, it seems to me that when I load a native app, the pixels that are on screen are things I can use, and the uncanny valley seems to be the modern problem, because that third-party content comes in pretty late, and then it blocks us. It keeps you from being interactive. So the pixels that are on screen go from being usable to being a bit of a lie, and what you really want as a user is to know when they're usable.
I think overall what seems that's missing is the relation between all those different key user moments. So suppose we do an optimization that like decrease the time it takes to get to interactive, but it increase the time it takes to get something on the screen. You might see like metrics that goes like people abandon page load more because nothing is happening for a long time. Right?
I'm trying to dig into the question of our user researcher has pointed me at some stuff that I haven't had a chance to dig into entirely yet, but to what extent does that initial acknowledgement buy you time, right? Because let's say your initial acknowledgement takes a long time. You're staring at a screen of white. That seems bad. You don't know that anything's happening. So there's I think intuitively also some value in a splash screen or a loading spinner or something that's a first meaningful paint.
Yeah.
How long does that buy you before the user gets annoyed?
Yeah, we need data on that.
And then once you've got that, right, you can count that as a discount factor. I think I also put up like in that conversation you found on Twitter, I put up a little formula, which is basically, the time to interactive, it's the max of time to interactive and contentful paint, minus potentially a discount factor for your time to acknowledgement. And your discount factor, the size of that factor is what I'm trying to figure out, but it's probably some percentage of the time that it took you to get it in. So if you can acknowledge quickly, you might buy yourself some time. But if you spend too much time, well, that doesn't really matter. You're dominated by your time to interactive.
Yeah, one question I have is just what, how much main thread availability do we need in order to, satisfy user input? And so like user input from, we have, taps to composited scrolls and then sometimes main thread scrolls, but like, let's say there's taps and there's composited scrolling, like how much time, like what is the time span and how much, space in there do we actually need to deliver a good experience?
Well, doesn't all that scroll stuff fall into the 60 fipsiness? Seems like it should cover that. And
Not quite.
No?
So if we're composited scrolling,
So I think the difference is that in this case, there's pretty much, we're trying to estimate the sort of latency you would expect. Like we can measure for input when it does happen, but we kind of want to model, how bad it would be if I had touched a second earlier, or if I had touched it all during that time.
I mean, this composited scrolling, the only thing that really matters is touch start performance, and that's basically equivalent to the longest task that's running.
It's just a single point.
If we have passive event listeners or some such, we'll be able to.
So it depends if there are. We could be doing composite scrolling with event listeners. If we assume there's no event listeners, then we just don't have to worry about scroll at all.
So composite scrolling with event listeners, do we go to the main thread once?
We go to the main thread at the beginning of the scroll. And when I did research on like how long you could block a start of scroll, it felt to me like I could notice lag after about 30 milliseconds. But that butts up against the Rail idle time saying you can run 50 milliseconds of script. So we kind of eventually settled on maybe 50 milliseconds is okay, because otherwise we have to change how long you're allowed to run script in Rail. So 30 to 50 milliseconds.
Yeah. Okay. And so then main thread scrolling is the only case where we need to have space on the main thread, like every frame.
Yeah.
Also main thread animations.
Animations, anything that's going to be script-driven interactivity. So I think about like we've done a ton of magic to like make scrolling awesome, because scrolling is the primary interaction. Also tapping links, right? Those are the built-in interactions that the web gives you. Everything else is user provided. If you look at a native platform, everything is content provided. There's no built-in like notion of like, we'll take these, you take those, and we'll fight over who gets what. It's all up to your app, basically. And so we have bought off this sort of disjoint view where, we spend a lot of time talking about scrolling because it's one of the primary interactions. But if I can scroll and I tap on a link and it doesn't work, right, what have we won? And so I'm hopeful that what we can do here is provide through Lighthouse or tools like Lighthouse feedback to developers that will let them know when they're on the wrong side of this. Obviously, blocking and scrolling, like defeating us, sucks, but they also need to get information that will help them stay interactive once we defer to them, right?
And the requirements for tap and scroll are completely different, which is what makes this tricky, I think. Like we say 150 milliseconds is fine for a tap, but 150 milliseconds in the middle of your scroll is no good.
What you said seems to be in contradiction with like core animation or like direct manipulation, where we have some platform provided effects that are disjoint from the stuff that you would write entirely in user space.
But to use core animation, you really have to sign up to it, right? Like as you're constructing your app, you choose to use core animation for a specific set of things because you know that you're going to defer that work to a system that can prioritize it and run it nicely.
It's like an analog to our accelerated CSS animation sort of thing, right?
Imagine that you had a CSS rule that you put in that enabled off-thread scrolling as opposed to providing it by default every time. That's the inversion that the web platform provides. We invert that relationship by default, and then we ask people to opt in to the other model, whereas native platforms do it the other way.
Cool. I only have a little bit left here, and so there's some questions at the end. I'd like to get folks' thoughts on. So I think one goal here is that as we have more mature definitions for these pieces, I left out battery efficiency and I left out some other things. But as we have more mature definitions, we're going to want to make sure that they're available in all the places. And you want to be able to characterize for a given load or given interaction that like we quantify it the same way across all of our tools that we use. And so, yeah, we're looking at, telemetry tracing, dev tools, UMA, and, how it gets out to developers, whether it's exposed to JavaScript or we expose traces to developers, et cetera. But like making sure that developers and us have the exact same numbers is good. It's something that I think historically we've had the two camps of metrics. And it's going to be really valuable to be looking at the exact same thing. Oh yeah, one note on being web exposed that I've been thinking about, representing the user perception with these metrics is hard. It requires a lot of details and considering how many characters of text have their web font loaded, etc. And so I think for us to provide the best quality metric that represents the user, it needs to be very close to the implementation. So I'm curious, like if FMP, for example, like could be specified and like could be a web standard, because it kind of TTI is another good one. Like the best definition is going to be very close to the platform, and it's going to be harder to have kind of a cross-browser implementation story for. So I don't know anyone else. Yeah. That said, I am crazy excited to like expose FMP, and TTI as soon as we can to JavaScript, and it might not be web standard. We do expose some perf metrics already like that. Okay. Yeah. So in addition to that, I don't have any more slides. These are some open questions around all this stuff that I think conversation still figuring this out. How does abandonment fit into all this? How does expected abandonment? Could we model expected abandonment based off of the difference between these things?
What do you mean by that? Do you mean like have some kind of formula that would tell like you end up in this situation when the user might go?
Yeah, I mean, I think to be honest that as we identify how abandonment fits in, like Charlie Harrison was saying, that they're looking at, if abandonment happens right before, before the first paint, then we know like all those resources took too long. If it happens after first paint, but before first meaningful paint, we kind of attribute it to the fact that first meaningful paint took longer than it should, right? So there's kind of a correlation to people dropping off and that thing, taking too long or just being unsatisfying. So I think that there might be a way to then say, you've regressed, your first meaningful paint is fine, but your TTI has been sliding out. Like you're running the risk of getting more abandonment. And this is something that we could kind of say when the site is in development rather than, relying on the RUM data.
So is the idea here that abandonment is like real data that expresses user unhappiness, and you could take all of the features that we've got and we could sort of learn a model for user unhappiness?
Yeah, that's kind of, I think this piece is kind of next level on top of the rest, but that is generally the idea.
It seems like abandonment might be hard to model because people expect very different things from different websites. Like if I go to Google Maps on my phone, I expect that it might take longer than if I go to someone's blog post. I'll probably be able to wait.
Yeah. Apparently, they also have huge amount of false positives, which are due to ad redirects and stuff like that, where it's not actually the user, and it's surprisingly hard to correlate what's actually a user abandonment and what's actually an ad just screwing you over. Yeah. Okay.
Yeah.
There is also the use case where you search for something, you go to a website, you get the first meaningful paint, but you quickly realize, okay, that's not what I want, and you go back. But that was success, right?
Yeah, another one here. Well, there was a thread. I guess Matt Welch started it around measuring some of this stuff across browsers, and yeah, that gets into the fact that what of these can be measured across browsers. today, and do shoot for having that in the future. Both there's discussions around kind of calibrating how important each of them are, and which matter more. What is the relationship as they shift in times? What matters? Memory use versus time of first meaningful paint is a good example. I think here, like my take on it at least is, we need to have these metrics in place first, before we identify and before we can even measure what matters more than others. Because the definitions might change, and that's going to move things around. Time to first contentful paint has been kind of standing in as a is it happening user moment, which is, is the navigation successful? And I'm not sure that it totally is. It's very close to it, but it's looking for text or image, and even getting the brand colors of like background color and foreground color painted would kind of be an acknowledgement of successful navigation. So there's some subtlety there. I think it might be fine for the moment. And there's been a few conversations around what if the sites themselves could kind of help guide us, provide us some signals, tell us, when they think visually complete is, so that it would help our guests. Or if we're looking at the web app case, if a kind of in-app navigation is about to start, if the page can communicate that to us, and we can we can start calculating things off of that. What kind of,
But if they do that, it means that they're using client-side instrumentation.
Yeah.
And they can capture their own bounce rate and these numbers and correlate them against each other. So you're not providing much help in that case. They kind of have that.
Well, they wouldn't be able to calculate TTI or speed indexers.
You're saying they are going to tell us what we are going to use information they provide to compute meaningful paint, which means that they have it, which means that they have both ingredients to make the conclusion.
They're going to have some, like the beginning of an in-app navigation is a good example. They know when that starts. They don't know when it ends.
So I guess it'd be interesting to provide them with that information.
Yeah.
The web-facing APIs with the meaningful paint and type to interactive.
Yeah.
To get it on their dashboards, like Bounce dashboard.
Yeah. Yes.
And they would get much better idea on which one matters.
Yeah.
And they would be actually a source of value for us.
I like that. Yeah.
You mentioned memory use here, but I didn't see that listed as one of the high-level metrics. Did we?
Yeah. I guess it didn't go here. Yeah, so I actually see, memory's kind of interesting. My take on it, at least, is that it doesn't like fall right here with byte efficiency and battery efficiency. Byte efficiency is like how much did it cost, battery efficiency is how much are you draining my phone. Memory efficiency is like how much, based on, you are consuming so much memory that it's slowing things down, and that's the user impact. So it's kind of like, the way that high memory consumption manifests to the user is my input latency is going up, other, just other effects to mostly, I think, latency. And so I'm wondering how we kind of connect to that and at least provide the attribution. One, that high latency is correlated to your existing memory use, and then get to a place where we could say your expected input latency is actually influenced by the fact that you are, consuming a lot of memory. And so we expect, swapping to be happening.
I think it's worse than that. Like, first your latency grows with memory, right? At some point in Android, you start kicking out applications or the apps from memory. And then going back becomes a problem. And you cannot easily assess that. And that is actually a much bigger hit on the user.
Really user-centric. Yeah.
And in order to tell how important memory is, we need to get the whole corpus of all data available to us over UMA or whatever, and that's where we make that conclusion, and that's how we can make recommendations to the user as to what memory guidelines are.
Right. Yeah.
Because you cannot solve it in isolation for the site or local, like the whole corpus of data. Count clicks.
Yeah, it is.
So some of the metrics we've got here, we'll collect them exactly once per page load. And other ones are more kind of continuous, like frame throughput, that kind of thing.
Yep.
Do we have any idea how are we actually planning on surfacing these? Like in UMA, am I going to want to record, here is one number summarizing the smoothness of the entire page load, or?
Yeah, right. Yeah, I think it's tricky. The expected input latency, looking at main thread availability, like in between the navigation start and the first paint, you don't care. Like there's nothing on that page, so we don't care about it being busy or not busy. So some of them are sensitive to like should be at least blacklisting periods of dealing with the page. But yeah, I agree. Like I think in UMA we would want to have we would at least want to break out smoothness by scrolling smoothness and animation smoothness and yeah, subset or at least bisect a few of these.
Sure. But we would still want that high level number, and it's not clear to me what the time scale of that high level number should be. Like we could say here was the time between each pair of successive frames in UMA.
Yeah.
But maybe that's less useful than here's the 90th percentile of frame timings for the duration from after page load till the user navigated away.
Yeah, exactly.
I don't know.
Right. Yeah, how do, there's some calculations on how we represent the input latency of all input on the page, like the 7 times I tapped, how we summarize that into one number.
Exactly. Or even whether we want to.
Right. Yeah. Not sure. I mean, yeah, Ben Hayden has some stuff on that considers peak end rule and all that stuff.
Right.
I think that generally is the path. But yeah, we just need to sort it out. Yeah. Any other thoughts?
So I'm not sure. Like first one for paint is what we want to track.
First one for paint.
So I think our from earlier was that we deprecate first one for paint, not first meaningful paint, but we your proposal is we still want it for the is something happening.
Yeah. I mean, I think we want a is it happening metric. And like I said, I'm not sure it is exactly first meaningful paint. I think that what we really want there is the first paint that is not all white. Yeah,
so
I think that might be it.
My concern are that it might so it's very easy to game that one. I mean, you can just paint something and you can be done.
Totally.
And I'm not sure if this is a good thing for user because it would penalize the first meaningful paint if you did some paint earlier. So
it will be failable because even if you like game the first paint, you will have to pay for it eventually, right? The first meaningful paint might happen later, or your time to interactive will not be good enough. So looking individually at all those metrics and making decisions about what's a good user experience is not good. You need like the collaboration, right? You need to understand how they relate to each other.
Yeah, so we're looking for a model of basically interactivity that, in my view, and that interactivity model like has got some perceptual discounts built into it. So we think that if you animate between 2 transition states, users feel like it's a better experience, even if it takes a longer period of time. So there's a bunch of like user experience stuff that our system is designed to enable, but we don't have a coherent model about yet. So the interesting question that I've been trying to come up with a model around is, why is it that native apps feel really good over the long term when you use them versus web apps, even though in general, we're much faster to getting you an experience. Like in general, we're faster. Like even with how bad the web is today, we're faster, but it's not reliable. So what is the discount that we would apply to reliability, for instance? So a user-driven or user experience-driven model of perceived performance is probably what I think we're eventually going to iterate to. And I'm interested eventually in tools that let you like take your logs and feed them into a tool to get a model back out to tell you whether or not you're doing well or doing poorly. But we're a long way from that today.
Any other thoughts?
So you're saying first meaningful pain is important, but there are other things that might be equally important, and we're not capturing them yet. Yeah. We don't really have a good idea of how to capture them.
I have some ideas. We can use Doug. Yeah.
How much do we care about this being actionable? I mean, we can judge the quality of a site very well, but as we make it more representative of how a user perceives the site, it's just like asking Doug, is it still crappy?
Yeah.
And Doug will say, yeah, it's crappy, and then you got to do a thing.
Yeah.
Time scale, Doug, is that the question?
Yeah, can you give me a bit more detail, Doug? Like,
Yeah,
what exactly can I do now?
Right. I think the relationship is the metrics that are even going to be closest to like user delight and user happiness, like are going to be kind of the least actionable. And like,
and so you provide a sensitivity analysis, right? So what you kind of want, what you see in like big complex metrics or like big complex solutions to multiple constraint problems is that you first get the, like, here's the result. And then the next thing you want out of the system isn't the number, it's the sensitivity analysis. Like if I change this number by this much, how much does it affect the overall thing? If I change this number, how much does it affect it? And you plug that in, you pull some sliders on it, and you can see if I improve this bit, it gets that much better. And that's what gives you eventually the ability to target your investments. And it's a very sophisticated thing to do. Most people don't have access to the data. We don't have the model to put it in, and then we don't have a way to drop the sensitivity analysis out of the model on the other side. So again, we're a long way from getting there, but I hope that we aspire to get that.
So it's a black box sustainability. First you measure, then you do A/B, and then you tune the numbers to get your A/B doing better. We don't really provide any sustainability. Like in terms of recommendations of what you should do, like based on a web platform, even advice, we won't be doing that. We'll be just measuring and saying, it is now better.
So I have this, like, imagine that you could take your server-side logs, your Google Analytics data, and then plug it all into DevTools in your development version and go tune that bit, right? Like that's cooking with gas.
I see, at least for your question, like I see these metrics as being kind of these guys out here, right? From like received on compositor to frame painted. And like, you know, if this goes up or this goes down and we know nothing else, like, yeah, that's not really actionable. You know, we need to know all these timings, you know, in between to start getting an idea of what is actually happening. So I think that's kind of the model, is that it gives us an indication, it gives us a place to start digging into, but we're going to need more fine-grained, a developer. Web developer may not want to walk through all of these, but they'll want to know how much time are we queued to wait for the main thread, how much time are the main thread executing event handlers, how much time to actually render the frame, like what is the breakout of those three pieces. And once I know that, then I'll be able to make a worthwhile change.
I can imagine something even like you see the number that says your frame throughput was bad, and then you like click on it, and it takes you to here's the part of the timeline where this animation janked, and you can see the main thread is busy there. And maybe we can do a little bit better than just showing the timeline, but we should be able to do at least that well. That would be hugely valuable.
I think that there is a lot of value to trying to expose these metrics to the web developer, because what could happen is that you would have analytics from vendors like compiling all of that data, and for your vertical, they might be able to say, you should definitely focus on nailing interaction or whatever, because this is a key driver of conversion, for instance.
And cohort analysis, right? They can say, in your industry, your competitors are this much faster.
As well, yeah.
The thing is, some of these problems are really tough to solve. Like getting your stuff broken down into tiny slices of work is almost a rewrite of your app. So my point is, even if we know that we've got janked up the main, it's really tough for a developer to fix that problem. And giving them help it's going to be, and load time. Like they're going to awesome.
So let me walk back a little bit and say that at a first pass, there are the end developers who we need to convince of the importance of this. But like when I talk to library authors today, their heads are basically in the sand. They understand that that their thing is fast. They're probably not testing on low-end phones. They don't have a good coherent model of what's good or bad, and they don't have a tool yelling at them. So, and their competitors are all doing the same thing. They're all doing this thing where they're like, oh yeah, we're going to make it fast by doing the server-side rendering, and then we're going to sit there, maxing out 2 cores on a low-end phone for 12 to 45 seconds, and they think everything is fine, right? They're not looking at any metric that tells them that it's on fire. It is absolutely on fire. So at a first pass, we can move the ecosystem of people who are informed actors and who would be more creative about coming up with things like pervasively slicing their work, right? Because once you've gotten into a framework, now you've got a way of doing this. Like what the Polymer guys came up with Purple because, in part, can't take credit for it, they did something super clever with Purple. But the goal that we got to was, I need interactive pixels on screen in 3 seconds on a 3G connection, right? Because like we'd had this conversation for a long time, and it would be like, no, you need to do more work asynchronously, more work asynchronously. And they'd be like, oh, but we don't like that model of building apps. And eventually they just said, tell me what you want. Don't tell me how to get it, just tell me what you want. And they were right, they were completely right. Me and Jake and Paul Lewis sort of arguing at them that they needed to do stuff asynchronously wasn't actionable for them.
Right.
We needed to unlock their creativity to allow them to go solve it. And what they came up with was better than anything that we thought that we didn't know that was possible, right? They came up with something so awesome because they were handed a goal and not a rule. So we have to give tools that give them goals.
What is Polymer?
So at I/O this
I'll
year,
just interrupt. Technically this session ended 90 minutes ago, and lunch is now until 2:15. So I think this discussion is going to continue for a
can
few
you put
minutes.
the purple thing up on screen?
But I don't know where it is.
Just search for Polymer PRTL.
Yeah, we gotta go.
Break out that one.
Sure.
That second one, yeah. So this is.
That's true.